Right. In BGP, we have message types, we have BGP states. These are the two places where you may get confused. We are not seeing message types. You know message types in BGP: open message, keep alive, notification, updates. Those are all message types. But this is while forming neighbor, while establishing peer. BGP undergoes some steps, which we call it as BGP states. Yeah. So BGP states: idle, connect, open send, open confirm, established. You see, when we configure neighbor, to that neighbor address, BGP have to do three-way handshake first. For that, it needs to find the route in the routing table. During the time of knowing the route to reach the neighbor, it will go from active to idle. Initially, it will be actively waiting for you to configure the neighbor IP addresses. As soon as you hit enter, it goes and checks the routing table to see whether it can reach the neighbor. That period is idle period. If the route is not there, again it will go to active state. Fine. Active state is not mentioned here, but that is what actually type 0, state 0, I can say. So once the route is discovered, it will try to perform three-way handshake with that neighbor by putting port number 179 as destination. It will try to negotiate, it will try to form three-way handshake. If three-way handshake need to be successful, you should have configured BGP on both the routers. If not, three-way handshake will stop after the two-way handshake. It will reset. Then it won't go to open send, it will go back to active state because connect state is not completed. Yeah. So connect state need to be completed. For that, we should have configured the neighbor addresses correctly on both the routers with right autonomous system number, with right neighbor IP address. Only then the three-way handshake gets over and it moves to open send. This is the first message, BGP message, with the router ID and autonomous system number sent as a message to the neighbor. Neighbor, after checking the open send, when a match is found with the neighbor statement, it confirms by sending open confirm message. In case if some parameters are mismatching, it is because of some misconfiguration. It cannot go to established state. It will go back to the beginning called active so that it can start again from idle. When all the necessary parameters that are sent between both the routers are good and open confirmed, it leads to established state. The neighbors now officially neighbors, which is called established state. Now, if you wish to check whether the neighbors are established or stuck in idle, you need to type this command show IP BGP summary. In that show IP BGP summary, like this, where it is show IP BGP, yeah. When you type show IP BGP summary, you should not see active or idle here. It should be something like this only. It says for last 2 minutes, 1 minute, 1 minute, they are all neighbors. And these many prefixes are learned. When you don't see a timer, instead if you see idle, which means you need to fix something, idle or active, which means you need to fix something. So idle is not good. You should see the uptime, neighbor uptime with some update, or no update is also okay. If you have 0 here, it is okay, which means the neighbor has not advertised anything. Now, when you type show IP BGP neighbor command, for each neighbor, you will find a detailed information, which will be for 3-4 pages, depends on the resolution of your screen. Usually we don't use this command because it is too big. So we type show IP BGP summary command to see the neighbor state. As I said, if some parameters are mismatching, if any one of this, then it leads to active state. Neighbor does not have route if there is no route to reach the neighbor, or if the source address from where the BGP packets are going or not matching with the neighbor statement, meaning you might have not said update source command. You may be trying to form neighbor using loopback, but you did not say update source. So if you know these reasons, you will be able to troubleshoot when the neighbor is stuck in active state. It may be because the BGPs are not using the correct source address to form neighbor, or the address of the neighbor is wrongly configured, or the neighbor statement is not configured at all, or the autonomous system number may be misconfigured. When you configure neighbor, you put autonomous system number, right? Neighbor may be in autonomous system 20, but we might have given 10. Right? See, if you make mistake in autonomous system number, it is very easy to find. How? You will get this error, exactly this error. This will be keep on coming in your screen. Many F. Immediately you should know it is because of autonomous system misconfigured. And when you correct the autonomous system number, then problem solved. Let me simulate this for you. Now you see we have a nice neighbor between R1 and R2. What is the command? Show IP BGP summary. We have a nice neighbor for last 6 minutes and we have learned one prefix. Wow, that's very great. But I'm going to make a mistake. Like I'm going to first give wrong autonomous system and I am going to show you how to troubleshoot it. Now, instead of configuring autonomous system 20 for this neighbor, I'm going to put 10. See what happens. Router BGP 10 here. This is locally it is 10. I say neighbor router 2's address remote AS is 20. And then what I do clear IP BGP start. I'm resetting, I'm clearing the what BGP has come. Oh, again I put 20. What should I put? 10. 30 or something, or 10 also you can put. Okay, I'll put 30. Again I will clear. See, immediately that FFF started coming, you see, the one which you saw in the presentation that says peer is wrong. Yeah, this keeps coming. Now let me fix this. I'll put the correct one. Now that bug will stop. You understood? Hooray. Nice. Now let us try one more mistake. Instead of putting 10002, this time I'm going to make mistake in the network. I put 112.0.0.2. What will happen? It will go to idle state, that's all. Alright, it will go to idle state. Now I cannot do that. Actually, what happens? This will take it as another neighbor. Anyway, no problem. I can show you that. Do show IP BGP summary. You can see that it is going to idle state because that never doesn't, it doesn't exist. It won't ping now, so it won't ping now, so it is in idle state because there is no route in the routing table. It is keep on looking into the routing table. Yeah, it's keep on looking into the routing table. All right, I remove this. This is one mistake, why the neighbor didn't come. Now let us make another mistake. We'll remove that the genuine neighbor, this 10 neighbor. We'll remove this neighbor and we will put a wrong address. Neighbor 10.12.0.22 I am putting, which is not correct. 2 is what correct. 22 is not correct. Okay, now let us do clear IPBGP stars. And this will not form neighbor when I type show IPBGP summary. Again, you see idle only. The reason is this is a wrong address. So when you don't see any log messages for this, but you can see here it is in idle state. When we fix this, the neighbor comes up. The neighbor comes up now. Okay, now let us do one more. What we'll do, we have checked wrong address, wrong network, wrong autonomous system, and if neighbor is not configured also, okay, it will come. Now we are going to do update source command. For this neighbor, there is no need to send update using glueback, but we will try to send. Sending the wrong source address is also a problem. Let's see whether we will get any. Okay, I have cleared And now, do we see anything like log messages saying unicast peer closed? Okay, that's fine. But we don't see any logs, but the neighbor will not come up. When we type show IP BGP summary, you still see idle because you're talking with your neighbor with the wrong source address. Now let us put the right one. When you remove this, the neighbor will come up. Okay, the neighbor has come back again. All right. So this is how we can troubleshoot. These are the silly mistakes we will make. Do you have any question? Hooray. Let's move to the next one. Okay, so authentication in BGP is very straightforward. You see, under the BGP, we put neighbor IP address and password. Very simple. We put neighbor IP address, password, keyword, and then the password. This is the password. This can be a name or alphanumeric or only a number. It can be a mixture of both. But this is not going to be sent. Instead, hash value will be sent. Let us do this lab. I'll go here and on router 1. We have neighbor already, but now what I'm going to do is, you see, I right click and say start capture, and I'm running Wireshark now, where we can see the BGP packets. So we have some BGP packets. Let me take the BGP packet and open the BGP packet. You don't see any authentication on TCP header nor inside the BGP header. But now let us go here to R1 and put some authentication. Router BGP 10 neighbor this password ABCD123. This is the password I'm giving. Now I'm going to reset by clearing the BGP. Clear IP BGP start. Hard reset I'm doing. ABCD123 is the password. I did not configure this on R2. So it started saying very clearly what the problem is. We are getting logs saying bad authentication. Router 2 is not having MD5. Let's verify that in the Wireshark. You see traffic coming from router 2 is not having anything, but traffic going from router 1, this is TCP header. This is TCP header. And hey, stay in one place. And let me open the BGP packet. BGP going from, no, this is a very old packet, 24. This may not have, yeah, this is not having password. Okay, then I want TCP with the port number 179 filter. Okay, this is all TCP with 179 and traffic going from 10.0.0.1 . MD5 signature. Under the option field, you have MD5 signature. But traffic coming from router 2, if you see, you don't have under the option TCP option, you don't see that MD5. That's the mismatch. Okay, so we are going to now go to router 2 and put the password. Router BGP 20, neighbor 10.12.01, password ABCD123. After I say this, you will start seeing BGP updates coming. All will become green now. Yep, updates everything. Neighbor established. Alright, so what I'm trying to say is it's not showing ABCD. It is not sending ABCD. What it sends is the message digest. It's the message digest. It's not sending ABCD123. Yeah, it's a message digest it sends. Alright. Any question? Wonderful. Let us go back to our learning. This is the command where, so show IP BGP command we use whenever we want to see what we advertise and what we learn from the neighbor. All right, when you learn a network, for example, this network, it says who is the next hop, from which autonomous system it is coming, and what are all the autonomous system in the path. If I go via this next hop, there are 2 autonomous systems. If I go via this hop, next hop, just only 1 autonomous system. Like this, all the attributes are also learned. Neighbor advertises not just the network, along with the attributes. Now, what is a RIB failure? If you see here, there is one R. R here means routing information base failure. Routing information base failure. What does that mean? It means that this particular network is given by BGP, also given by some other source, some other protocol, or it can be even a static route with a better administrative distance. Say, for example, if I am learning from an IBGP, administrative distance will be 200. Now, if the same network is given by OSPF, administrative distance will be 110. Which one router will follow? Router will follow OSPF. Why? Administrative distance lower is better. I repeat, if this network, which is given by BGP, is also given by OSPF, router A will not use BGP's given route, it will use OSPF given route. Why? Because the administrative distance lower is preferred by routing information base. When you type this command show IPBGP RIP failure, it says that these 2 networks cannot be used. These 2 networks given by BGP cannot be used because BGP's administrative distance is higher. What does that mean? It means that router is following some another protocol's given route. Is this clear, RIP failure? Yes, correct. No. You're confusing yourself. We did not inject anything here. One router we have. It is learning that network from OSPF. We don't know how OSPF got it. Maybe someone advertised the same network in OSPF. Someone also advertised in BGP, and this is an IBGP. This is 200. Same network given by OSPF is 110. So it won't follow BGP's advice, it will follow OSPF advice. This is not injected route, this is not redistributed route. That's what I'm trying to say. Here there is no resolving needed. Oh, because of the word failure, you think we need to resolve. No. This is just telling a reason why it is not using BGPs. See, we need route. Route is given by BGP or OSPF, that doesn't matter. Same network only, no. It is going to use OSPF decision, not BGP's decision. That's what it is trying to say. Now, whenever I do some changes to neighbor or attribute, you might have seen I put the command clear IP BGP star. What does that star means? All neighbors I want to clear up and re-establish. I want to clear up. I want to remove the neighbor. I want to reset the neighbor, and I want to re-establish. We call this as hard reset. That is one way of refreshing the route. Doing hard reset. But if I put the word soft here, it becomes soft reset. What is the meaning? We don't remove the neighbor. We still try to re-establish one more time. We keep the neighbor and re-establish one more time. This is what called a soft reset. Instead of saying all, you can also specify one particular neighbor address like this. You can specify a neighbor address, both in hard reset and soft reset. In soft reset, you can also say in and out, only refresh outbound update, only refresh inbound update, and so on. All right, whenever you clear, you can also debug and see what all it sends and receives. When you clear, it will re-establish. So all the updates will be resent. Those things you can see. This is just for verification. All right. So in this chapter, we learn lots of information, and I will encourage you to collect all the videos of this chapter, go through it one more time, and come tomorrow so that we can learn BGP attributes.